Okay, going on to concavity. So concavity stuff. Now let's just get rid of this page here. Concavity stuff. So we start with the second derivative. So let's just recall that y was equal to the square root of 3x plus 2 sine x. Then we found that y prime was square root of 3 plus 2 cosine x. And I didn't say it before, but be sure you check your derivatives twice. If you get that first derivative wrong, everything else is going to be wrong, but that looks good. So that means my second derivative, square root of 3 is just a number. It's a constant. I'll have students do funky things because it's square root of 3 as opposed to something like 12. It's just a constant. Derivative of constant is 0. That 2 is just a coefficient. It just stays there. Then the derivative of cosine is minus sine. Now I find my possible inflection points. I set my second derivative equal to 0, which gives me sine x equals 0. Then I ask myself, on the interval from 0 to 2 pi, where does sine equal 0? And sine equals 0 at 0, pi, and 2 pi. Then I can make my concavity chart. I've got 0. Remember, we're on the interval from 0 to 2 pi. So I'm going to start at 0, go to pi, pi to 2 pi. So that's all I need for concavity here. Test value, anything between 0 and pi. I'm going to pick pi over 2. Anything between pi and 2 pi. I'm going to pick 3 pi over 2. Then I plug into the second derivative. So my second derivative is right here, negative 2 sine x. So if I plug in pi over 2, sine of pi over 2 is 1. 1 times negative 2 is negative 2. So that's going to be negative. Plug in 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 1 times negative 2 is positive 2. So it's positive. And so that tells us that f of x is concave up and down. And because we see an actual change of concavity, we do have an inflection point at x equal pi, y equal f of pi, always the original function for y coordinates. And because they're graphing, I'm going to let you use decimals here. So when I plug pi into the original function, hopefully I get correctly 0.54544, and so pi 544 is my inflection point. And so there are all my calculations. Now it's time to put a graph together. So I'm going to go on the next piece of paper and write down the important stuff I found. I found that we had a local max at 5 pi over 6, 5.54. We found that there was a local min at 7 pi over 6, 5.35, and then we had an inflection point at pi 5.44. That's everything we found. Okay, so my important x numbers, 5 pi over 6, 7 pi over 6 pi. And remember, we are only going from 0 to 2 pi. Then all my important y values are close to 5. So you want to give yourself enough room to actually do this well. So here's what I'm going to do. And this is okay as long as you label. Okay, so I'm going to count by pi over 6. So there's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then it would be 6 pi over 6, but that's pi. Then 7 pi over 6, and I keep doing it, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6, which is 2 pi. That I counted by pi over 6 because that works so well with my x coordinates. Now, yeah, a lot of these things down here simplify. Yeah, I don't really care about that. I simplified the ones I needed to simplify. I simplified pi, 2 pi. A lot of these other ones simplify too. If you want to be a perfect person, go ahead and simplify them. I don't care. Now, this guy up here. Now, this is going to be a little unorthodox, but as long as you label, that's fine. I'm going to call that 5. And as long as I've told my reader that that's 5, it's okay. And well, I'm going to go up a little higher than that, just maybe a little. Let's call that 5. And then look at the numbers I have to do there. 5.44, 5.35, 5.54. So I'm going to call this 5.1, 5.2, 5.3, 5.4, 5.5, 5.6. That will nicely tell me what's going on. And then I'm going to go ahead and get 2 more points here. My endpoints. Because they told me very definitively 0 to 2 pi, at x equals 0, y will be f of 0. And that's square root of 3 times 0 plus 2 times sine of 0. That's going to be 0. So I have the endpoint 0, 0. And at x equal 2 pi, got y equal f of 2 pi. So square root of 3 times 2 pi plus 2 sine of 2 pi. Well, that's going to be 2 square root of 3 pi, which gives me 2 pi, and that is approximately equal to 2 square root of 3 pi. That's approximately equal to 10.88. So let's plot what we know. We know we have a point 0, 0. We know we have a point 5 pi over 6, 0.54, which right about there. And we know that's a max. We have pi 5.44, maybe right about there. And that's an inflection point. And we have 7.5, 7 pi over 6, 3.5, maybe right about there. And it's a min. And then finally we have the last endpoint, 2 pi, 10.8, 10.85. We'll just stick that clear up there. And so now I need to connect the dots. 1, 2, 3, 4, 5. Now you aren't going to write on your paper, so we can see that there. See, there's that last dot. You couldn't see that. That's that last endpoint, and I just put it up way up high. You don't have to connect, write down the order in which you're going through the dots. It just helps me demonstrate what's going on. So then looking at our charts, I should start by being increasing and concave, Wrote those backwards, didn't I? See, you catch little mistakes here. Negative means this is concave down. Positive means this is concave up, down and up. So increasing, concave, down. That's how I go through these first 2 points. Increasing, concave, down. And now your points are going to guide you. That's a maximum. What's going to happen as a maximum? I change from increasing to decreasing. Then I hit an inflection point. At inflection points, concavity changes. It's currently concave down. You change it to concave up. It's currently frowning. Change it to smiling. Then I go to the next point. I hit a minimum. At a minimum, you need to switch from decreasing to increasing. And go to the last point. And there's my graph. And if it fit all together, you are almost certainly right. But now we can check it. Now I already have the function in there, so just give it an appropriate window. So the window I used was 0 to 2 pi. And I counted by pi divided by 6. And here I'm not going to be able to get the same resolution I did on this. I'm just not, but we can see what we get. And I'm just going to go from 0 to 11 because this top point up here was 10.88. And so let's see what we get and graph it. I forgot to change my step. And to me, if I was almost out of time, I would feel good about that. That I do see the same basic shape, it's just that this part in here isn't as exaggerated. Here we really exaggerated it by the way we labeled things. Here, not as exaggerated because I didn't do that same sort of labeling. But if I was almost out of time on a test, I would feel good about that. That looks basically the same. If I want to zero in on that middle bit part, I could. So I'm going to press window again and really zoom in on that window part. And so I'm going to, that middle part, I'm going to go 5 to 6. So just really zooming in on that middle part. And I'm going to count that by 0.1s. And so we're really just going to see that middle part and see if we get that same sort of exaggeration when I zoom in on it. And when I zoom in on the middle part, kind of doing the same thing I did before, counting from 5 to 6 by 0.1, I get the same shape. And so it absolutely checks. And then comparing this to the button that always seemed to work before, zoom 6, there's what you get on zoom 6, the standard window, and that's not at all what was wanted. And so again, the point here, I can't make the machine do what I want until I give the machine the good numbers. And so this absolutely did check. And we'll end this video, and on the next video, we'll start talking about asymptotes.